Hello, this is Scott Dahman of PowerWorld Corporation. In this session, we'll take another look at PowerWorld's text file format, the auxiliary file. In an earlier session, we looked specifically at the data sections, which can be used for saving information from a PowerFlow case or loading information into an existing PowerFlow case. In this session, we'll take a closer look at the script sections. The script sections can be used for running batch scripts and performing actions on the PowerFlow case. And basically anything you can do through the graphical user interface, you can do with a script statement. So things like solving the PowerFlow, running an available transfer capability calculation, or performing fault analysis can be done with script statements. A single auxiliary file can have multiple script and data sections. Within the script sections, they always start with the word script and then an optional script name on a single line, followed by an open curly brace, and then one or more script statements which conclude with a semicolon. After all the script statements, then there's a closed curly brace to indicate the end of the script section. This slide summarizes the features of the data sections. Here we see details of the script section format. Again, the section always starts with the word script, and then an optional script name may follow. The purpose of the optional script name is to identify that section so that that section could be specifically run from another auxiliary file or from a script action on the command line in Simulator. Then the script actions follow inside the curly braces, and each statement ends in a semicolon. In Simulator, let's open our B7 flat case and look at an example of an automatically generated auxiliary file with script sections. One such example can be found with the limit monitoring settings. If I click on the Tools ribbon and then open the limit monitoring settings, I can click on this button here that says Save Monitoring Settings, which will save the settings presently in the case out to an auxiliary file. I can give it a name. I'll just call it Limit Monitor. Then click Save. And this dialog is asking me which key field that I want to use for elements, bus number or bus name in nominal kV. You can also use labels. I will just choose the number, and it saves off the auxiliary file. Now I can open the auxiliary file and look at what was created. I'm just going to use a shorthand here to get to the Windows Explorer so that I can open the file in a text editor. If I click on the Save Monitoring Settings again, and then find the file, limitmonitor.aux, I can open that file with a text editor such as WordPad. In the auxiliary file, I can see multiple data sections that are used to save some of the options for the limit monitoring, such as ignoring radial lines and the definition of the default limit set. If I scroll down through the file, I can see that there are several script sections also. This script section is used to first select all of the buses in the system and then set the limit monitoring status for each bus to yes and assign each bus to the default limit group. Finally, all the buses are unselected and the script section ends. Other script sections do similar things for identifying the voltage limit settings for the buses, for monitoring the branches, and the interfaces. When you interact with PowerWorld Simulator through the graphical user interface, some actions require you to be in edit mode, such as when you're modifying the topology of a case. And some actions require you to be in run mode, such as when you want to solve the power flow or run a contingency analysis. When you're interacting with Simulator through the script sections of an auxiliary file, you also have to obey submodes within, especially within run mode. Edit mode really just has one submode, called the case submode. But run mode contains several submodes, such as power flow, contingency, ATC, fault, PV, and QV. For example, to perform contingency analysis using script commands, you have to first change into the contingency submode. These different submodes are similar to dialogues that you open using the graphical user interface. For example, if you wish to run contingency analysis in Simulator using the user interface, you first have to open the contingency analysis dialog. In the script file format, there's a command called enter mode, which has an argument for specifying the mode or submode, which you can use to switch between submodes. A help manual is provided with Simulator to describe all the different script submodes and the different commands which can be executed in each. If I go to the Window ribbon and then click on the button that says Auxiliary File Format, it will open a PDF file called Auxiliary File Format, which is a manual that describes the format and all the script commands. So I can see here in the table of contents, it describes the script section and then different actions which are under the heading Generic Data Actions. These can be performed in any mode or submode. There are also certain actions that can only be performed in edit mode, such as equivalencing, merging buses, tapping transmission lines. Also, if you wish to use data sections of auxiliary files to create new objects, such as adding a new bus to the system, you must first use a script statement to enter the edit mode before you can make those changes to the topology. Here we see several actions that are available in run mode, and the power flow submode, the contingency submode, and so on. If I page down into the document a little bit further, I can see more detailed descriptions of each of the available script statements. These are the generic actions that can be performed in any mode or submode. So things like renaming the file, copying a file, or loading an auxiliary file can be performed in any mode. And then a detailed description follows, which shows the arguments in the syntax for each statement. If you don't have this file, you can also download it from our website. Go to powerworld.com, then go to Downloads, and then Simulator aux file format. From here, you can download the manuals with the auxiliary file format for several different versions of PowerWorld Simulator. Simulator also has a scripting command line window that you can use to enter script commands directly from the user interface. This is particularly useful for testing script statements before you attempt to run them from an auxiliary file. In Simulator, I can go to the Tools ribbon and then click on the Script button. This opens the command line window, and here I can enter a script command. For example, I could type in enter mode and then in parentheses edit. Then I have to place a semicolon at the end, just as I would at the end of this statement inside the auxiliary file. And then when I click enter, it will issue the command. And I can see here that I've switched from edit mode to run mode. I can also switch back using the enter mode run statement. From here, I can also click on a button to show the message log, so that if there are any problems with the script statements I entered, it will explain them in here. Here I can see it just echoed the script statements that I entered, and they were successfully executed, as there's no message to tell me otherwise. Within the script command window, there's also some items under this auxiliary file tab which allow you to load auxiliary files or validate auxiliary files. Another feature is the quick aux, and I can click on define, and from here I can click on the add button to select a frequently used auxiliary file that I may wish to quickly load from within Simulator. So for example, the limit monitoring file that I just created, if that's something that I may want to refer to frequently, I can add it to the quick aux. It lists it right here, and if I want to continue to add multiple files, say this B7 fault example.aux file, if I have more than one, I can also change the order of them, and that will change the order in which they appear under the quick aux menu. If I close this window and then click on the quick aux again, I can see the different files that I've added under the define option. Also, if I close this window and then back on the Tools ribbon where it says Script, I can click the drop-down arrow and then quickly access the auxiliary files that I've saved as quick aux files. So that can be very useful if you repeatedly run certain auxiliary files or load them. You can also load the auxiliary files in other ways too, such as clicking the Open Auxiliary File from the Quick Launch toolbar or from the script window, loading an auxiliary file, or from most case information displays, you can right-click in the grid and then load auxiliary files from there. Also, from the script command execution dialog, there's another menu option for exporting field names, which can be used to dump the field names to Excel or to a text file. This gives you a complete list of field names in Simulator for all object types. The next several slides list many script actions which are available in different modes and submodes. So for example, on this slide we have examples of script actions which are available in all modes and submodes. Here are some examples of actions that are available in the case submode of edit mode. And again, for a complete list of all these actions and the different modes and the arguments and syntax of each action, it's best to refer to the PDF manual. Some run mode actions can be executed from any of the run submodes, while others require particular submodes. Here's an example of different commands that can be issued from the PowerFlow submode of run mode. And the contingency submode, the ATC submode, the fault submode, the PV submode, and the QV submode. Another feature within Simulator that makes use of automatically generated script files can be found in the difference case tool. The difference case tool can be used to build an auxiliary file that shows topology difference between two different cases. This can be very useful in documenting topology changes between cases. You can also use it to first modify or augment a case using the graphical user interface and then capture those topology changes in an auxiliary file. That auxiliary file can then be run on a different copy of the original case to produce the changed case. This feature can be used to compare two different cases. For example, I can compare this year's PowerFlow model to last year's PowerFlow model from the same source and see what's changed. To use it in this manner, I first go to the Tools ribbon, then choose Difference Flows, then set the present as the base case. From here, I can then open a new PowerFlow case. So for example, I could open a 5-bus case, B5R. I'll choose not to save the existing case. And from here, I can go back to my Difference Flows tool and choose Present Topological Differences from Base Case. Here I can see a summary of items that were removed or added to the case. I can also choose to get a detailed look at different elements. So if I click on the Elements Added tab, I can look at loads and see that my new case has a load at bus 1 that did not exist in the other case. I could also look at transmission lines under branches, and I can see that my new case has a branch between bus 3 and bus 6 that did not exist in the other case. I can also look at elements that are removed. From here, I can also save the different lists of added or removed elements to an auxiliary file. I can also use this feature to document changes that I make to a PowerFlow case. For example, if I close this dialog and then return to the 7-bus case, B7 flat, I can continue to keep the same base case in memory and then switch to edit mode and then actually make changes to the case. I'll switch to the Draw ribbon and then use the one-line diagram to make changes to the case. For example, I could add a new bus. We'll call it bus 8 to the case. And let's say I'll add it to area left and leave all the other options at their defaults. I can also add a generator to the bus and say give it a megawatt output of 100 megawatts. And then new transmission lines to connect the bus to bus 6 and to bus 1. I'll enter some parameters for the series resistance and series reactance. And I'll enter some parameters for this transmission line. I could also clean up the appearance of the one-line diagram if I wish by selecting objects and moving them. I can also change the formats of some of my newer objects if I wish. Let's also delete the existing transmission line between bus 2 and bus 6. I can click on it and then hit the delete key and choose to remove both the objects and the records. Now I can switch to run mode and solve the case. Then I can go to the Tools ribbon tab and back to difference flows, and then present topological differences from base case. Here I can see that my case has one new bus, a new generator, two new transmission lines, and one removed transmission line. And of course I can use the different tabs here to browse what's changed in the case. Then I can also go down here and choose to save elements that have been added or removed to an auxiliary file. I'll first choose only elements added and then save to the aux file. And I can give it a name. For example, add bus 8.aux. And then click Save. And I'm just going to choose not to save any bid curve subdata. I don't believe I have any in the case. But I'll also say no to the reactive capability subdata. Then I will choose only elements removed and save those to the aux file. Here I can choose the same aux file that I just created. Click Save, and then choose the option to append the new information to the existing file. Now I can open the file in an editor such as WordPad. I'll just click the Save to Aux file again as a shorthand to get the Windows Explorer open, and from here I can right-click on the file and choose to open it with WordPad. Here I can see a description first of the elements that were added to the present case. So for example, bus 8 is described in this data section. The generator at bus 8 is described here. The two new branches, and then the section which describes the elements that were removed. In this case, a script action is first used to unselect all of the branches in the case. Then the selected field is toggled to yes for the branch that I removed between 2 and 6. Finally, a script action is issued to delete the selected branches, which in this case is only the branch between 2 and 6. So by running this auxiliary file, I can in effect change the 7-bus case to the new 8-bus case with all the topology differences that I performed through the graphical user interface. I might also choose to add another script statement at the top of this file to change my case into edit mode. That way, if I load this auxiliary file while in run mode, I'll make sure that I'll switch over to edit mode so that I can add these new buses to the case and remove the transmission line. I could then save the file and then use it as needed. I could also make use of Simulator's auxiliary display format to keep track of the changes that I made on the one-line diagram and to document those. So I could switch into edit mode and then to the Draw tab, and I could use various means to select the objects on the one line that I added. So for example, I could use this select region to pick multiple objects and then hold down the Shift key. And I might also pick the objects that I moved or relocated in order to make room for the new items. Then from here, I can go to the One Lines tab and then choose under the List Display to show the selected display objects. With only the selected objects shown in the Display Explorer, I could right-click and then save this information as a display auxiliary file. I could give it a name, again, such as Add Bus 8, but with the AXD extension to designate it as a display auxiliary file. With this information, I can reproduce the changes that I made to the topology and to the one-line diagram. To demonstrate this, I could reopen the B7 flat case, choose not to save the existing case, then load my auxiliary file called addbus8.aux. Some confirmation dialogues will pop up for the new objects, such as the bus described by bus number 8. I'll just choose to add all of these to the case. And for the generators, and for the branches. Now the items have been added to the case, but the one-line diagram is still the same. I can see here that I have a series of unlinked objects that refer to the branch between 2 and 6 because that's the one that was removed. I can also open my message log and I can see exactly what happened. First, the script statement was issued to change to the edit mode, and then data records were read for buses, generators, branches, and then also the script action was executed to remove one branch. If I open my Model Explorer, I can verify that the new objects have been actually added to the case, even though I still don't see them on the one-line diagram. So bus 8 is present, as well as the generator at bus 8, and the new branches between 8 and 1 and 8 and 6. To update the one-line diagram, I can right-click and choose to load the display auxiliary file. I'll choose the addbus8.axt and then open. Confirmation dialogues will also show up for items that I'm adding to the one-line diagram. In this case, I'll just choose yes to all. And now the new items have been added to the one-line diagram. If I wish to get rid of the unlinked objects, I can quickly just open the unlinked display objects and then choose to delete them. Now I can see the changes on the one-line diagram as well. So the auxiliary file format, through the use of data and script sections that are automatically generated from within Simulator, can be used to document changes in the PowerFlow case and in the display one-line. The slides summarize the procedure for using the difference cases to identify the added elements and the removed elements and save them to the auxiliary file. Here's the example with the one-line diagram and the changes that we made. And then a screenshot from the present case topological differences. And then if we wish, we can open the auxiliary file in a text editor and make some changes, such as a script action to enter the edit mode. And then if we wanted to make some other changes to the rest of the file, we could certainly do that as well. Then we can reopen the case and load the auxiliary file, and then actually make the changes. And then we can do the same sort of actions with the display objects, using the Display Explorer and then saving the new objects to the auxiliary file. That concludes this session on auxiliary files and the script sections. If you need further assistance, please feel free to look us up on the web, give us a call, send email to our support line, or if you prefer to work with a particular PowerWorld engineer, please feel free to contact that person directly.